Hi and Assalamualaikum. We are from Group 13. We will present our proposal about Gufu detector. So Gufu in Japanese word it means tornado. So moving on. So here is our content for our presentation. Next. So me, Farid Aziz as project manager. We have Ain as finance manager, Ilyana as hardware and software lead, and Aiman as for our integration and product lead. So moving on. So the problem statement, why we do Gufu detector. So the issue addressed by study that we have researched is that Malaysia did not prepare with any tornado detection to warn people or evacuate them to a safer location before the phenomena occur. So like as we know, tornado rarely happen in Malaysia, but in recent time, there is quite a number of cases about tornado. So the other problem is that tornado detection in Canada only can identify tornado formation 30 minutes before the formation happened. So like it have lack of information since it use Doppler detecting infrared from the satellite. Moving on. So here is our objective, which is the first main objective for our project is to give early warning. Our objective is to make sure people in Malaysia get early notice about tornado since tornado is rarely happen in Malaysia. So we need to make sure that people in Malaysia get prepared with tornado. And for the second objective is about monitoring changes. Our other objective is to get readings from our sensor so that it can notify us if there is changes in the parameters. So I will pass to Ain.
Thank you, Farid. So now I'm going to explain on the literature review. So in total, we did collected 10 articles, research papers, and also technical papers on how to build our project. So as you can see on the screen, there are there are 5 highlighted literature review. So this one, these highlighted titles play prominent roles in completing, in giving ideas to build this project. So the first one is on the wind speed monitoring and alert system using sensor and weather forecast. So this title, for this research paper, it gives us a lot of information on the wind speed and also on how to detect how to build a device to mimic the wind speed and also on how to detect the wind speed. So as for this one, the research paper said that we need to convert an analog signal into the wind speed, and then we're going to use Arduino for that. And also next we have the IoT-based weather station. So since our device should be an IoT-based solution, we need to include the IoT feature as well. So this IoT-based weather station included 3 sensors, which are the barometric, the wind, and also the direction of the wind sensors to measure the pressure of the wind and also the direction of the wind so that they could detect the upcoming tornado. Next, we have the real-time weather monitoring system using IoT. For this one, it's kind of the same, just like the IoT-based weather station. So we're going to use these 2 as a reference for us to build an application to integrate our system to become an IoT system. Next, we have the early tornado detection. So in early tornado detection, the writers wrote that they could actually produce infrasound using what do we call it? Pantene, if I'm not mistaken. They use Pantene flame torch to produce infrasound because we're going to simulate this, but we don't have the real time, in real life tornado occurrence. So we need to mimic infrasound for infrasound detector to detect the infrasound. Next one is the infrasonic wave detection. The prototype rollout. For this one, we refer to this in order to build our own infrasound sensor, because generally infrasound sensor is not widely available, and if it does, it's going to burn a hole in the pocket to pay for it. So instead of burning a hole in the pocket, we decided to create one. So for this infrasonic wave detection, we plan to build our own from scratch. So we need to have a microphone, and also the microphone will detect the infrasonic sensor that we have referred from the early tornado detection papers, and then the detected sound will be passed through the low pass filter and then get into the microcontroller, and after that the infrasound sensor could be detected. I think I pass this to the next presenter. Thank you.
Okay, I'll continue from this part. So with all the problem statement and reference that we have researched on, so we are coming up with the block diagram for our Gufu detector. So the input, as Ain has said before, so we are going to have infrasonic sound output, which is used as our input, the RGB color sensor, and also wind speed output, which later will be presented by Aiman. And later, after the data has been acquired, will be sent and processed in ESP32, which is our main microcontroller. It also has IoT features with it, so that's why we can send and retrieving data from Meet Apps Inventor. For this project, we're going to use Meet Apps Inventor as our application, and later we will instruct the output, which is the piezo buzzer, to produce a loud sound whenever there is a tornado warnings that we have detected. Can you go to the next slide? Okay, so with that being said, this is the features in the systems. So one of it is amplifiers were used for increasing the small output voltage of the infrasound signal that we obtain from the mic, and the RC filter, which is the low pass filter to eliminate the high frequency noises. The microphone was to detect and record infrasound signal. The RGB color sensor is used to detect and record the changes in the color of the sky. Basically, we're finding the green color to detect the tornado. Is actually one of the tornado signs based on the paper that we have researched. And next is wind sensor. This wind sensor actually to detect and record the wind speed by calculating DC output formed by the sensor, so that we don't get the false alarm or warnings from the two color sensor and also the sound sensor that we have obtained. And last one is the piezo buzzer. It's actually the output of the main controller to produce the loud sound so that it can alert everyone. Next. Okay, so basically this is the overall system flowchart. So we're going to start by collecting the infrasound for the infrasound system, that custom infrasound system. And then if the infrasound system falls within the range of 0.5 to 21 Hz, we are going to collect the data of the sky and wind. So like Farid has mentioned just now, one of the problems that we face today is the fact that we can detect tornado 30 minutes prior. And based on the paper that we have researched, infrasound can be produced by the tornado an hour before. So this is the main reason why we check on the infrasound first. Then we check on the sky's color and wind speed to avoid any false warnings. After that, we're going to check whether the color sky is greenish and whether the wind speed is larger than 64 kilo per hour. And if it does, then you're going to alert the residents on the tornado warnings on the main controller that has the piezo buzzer alongside with from the mobile apps that we are going to create. And if it's not, then you're going to repeat the system. The system will repeat itself. And next, I'll pass to Aiman.
So for the programming flowchart main program, it is starting with the bird alert, which is the buzzer. So it will looping the system, starting with a tornado detection. And if it is true, digital we write buzzer as a high, which it will produce a sound. And if it is low, we will move to the next slide. So here is the programming flowchart tornado detection function. So it's starting from the main function, which is to initialize bull infrasound, green sky, alert, wind speed, and to false, which is we detect it first. And it's starting with infrasound detection for our first sensor, and continue with green sky detection, and the last one which is wind speed detection. This is three sensors we use to avoid the false alarm. So for the wind sensor, moving to it is measured based on the National Weather Service, which is the Fujita scale of tornado intensity. So there is some scale for it. We classify it into 6, which is F0 for the tornado, 40 until 72 mph, 73 until 112 mph for F2, 113 until 157 mph for F2, 158 to 106 mph for F3, 207 until 260 mph for F4, 261 until 318 mph for F5. So if the wind is through false, it will print not tornado infrasound and green sky detected. And if it's moving on to infrasound, if it check if all three sensors are true, then if it's true, it will print the tornado alert, which is will give siren sounds to the community. So for the next slide, this is our programming flowchart for infrasound detection, which is it start from the read audio signal from the microphone, and if we check the signal frequency, if it is whether from 0.5 Hz until 20 Hz, and if it's yes, it will send the data to the ESP32 and the buzzer will turn on. If it's no, it will keep repeating the read audio. Next one. This is for the programming flowchart green sky detection function, which is we will define the input here and the P model. And it will detect if whether the green color is high or not, and if it's high, it will return true as it will print green sky detected, and if not, it will keep repeating to read the output, read the input. So then the next one. This is programming flowchart wind speed detection function. So this is what I told before, which is the wind speed is measured from the National Weather Service, and if all the condition is written true, it will go send to the RS32, which for further to check if there any false alarm, and if all three sensors are true, and it will turn on the siren. So the next one. So that's all from us. Thank you.